The nervous system is designed to orchestrate all the processes in the body, not just thinking and not just behavior. It really can be divided into 5 things. So there's sensation, and sensation is really bound or restricted by the receptors in the body. So receptors in the eye that perceive photons, light energy, receptors in the skin that perceive pressure, touch receptor, smell, taste, hearing, etc. The nervous system of humans is designed to extract physical phenomenon from the universe that are non-negotiable, photons of light. I can't see in the infrared with my eyes, and I can't see ultraviolet light with my eyes, and I can't perceive that because I don't have the receptors for it. Other animals can perceive some of those things, but that leads us to the next thing, which is perception, which is which sensations are you paying attention to? So all the time you're sensing things. Like right now, your feet are sensing the contact with your shoes, but you're not thinking about it until I say that, and then you shift your perception. Right. So perception is like this spotlight. So the brain wants to constantly bring in sensation. It's non-negotiable what's coming in. It's just dependent on your environment. Perception is negotiable. You can control that because I just said shoes and you thought about your feet and there you are. Then there are feelings, which can be a little bit nebulous, but feelings are a link between our emotion and it generally invokes the body, sensations in the body and concepts in the mind of what those sensations are about. That's really what emotions are. And then there's thoughts. And thoughts are interesting because thoughts happen spontaneously. Think about like a web browser that's constantly giving you pop-ups, but thoughts can also be deliberate. So you and I can decide right now that we're gonna think about a plan for something, or we're gonna think about what's going on in the world. So thoughts happen spontaneously and they can be deliberate. And then the final thing is behaviors and actions. So the nervous system is responsible for sensation, perception, feelings, thoughts, and behaviors. From birth till about age 25, the brain is extremely malleable in a kind of almost passive way where kids are exposed to things and the brain is just wiring up. I mean, the brain is really designed to adjust itself in order to be in concert with its surroundings and to optimize that. The brain is basically designed to be customized in the early part of life and then to implement those algorithms and that circuitry for the rest of its life. And so the brain can change in adulthood, and it can change provided that there's an emphasis on some perceptual event. So in other words, if you want to change your brain as an adult, let's say you want to be less anxious, you want to learn a new language, you want to be more functional in some way, presumably. The key thing is to bring focus to some particular perception of something that's happening during the learning process. And the reason for that is that there's a neurochemical system involving acetylcholine. And it comes from these 2 little nuclei down in the base of the brain called nucleus basalis. All day long, you're doing things in a reflexive way. But when you do something and you think about it very intensely, acetylcholine is released from basalis at the precise neurons that were involved in that behavior, and it marks those for change during sleep or during deep rest later. So for people that want to change their brain, the power of focus is really the entry point, and the ability to access deep rest and sleep. Because most people don't realize this, but neuroplasticity is triggered by intense focus, but neuroplasticity occurs during deep sleep and rest. So when we're talking about focus, I think it can get a little bit vague, but it might be useful to think about like what exactly is focus and what triggers plasticity. So the brain loves to be able to just do things, pick up coffee cups and drink and walk and talk and do things and not put much energy into it. When we decide to focus, what the brain really does is it switches on a set of circuits that involve the frontal cortex and nucleus basalis and some others, and it's trying to understand duration, how long something's going to last, path, what's going to happen, and outcome, what ultimately is going to happen. So duration, path, and outcome. The events of early 2020 are a good example of this. One of the reasons why it's so exhausting to be alive in 2020 is because we are now having to pay attention to duration, path, and outcome. How long is this thing going to last? When are they going to open up all businesses? Did I touch that door handle? Does it matter? Right. Who are the experts? Are there any experts? There are a lot of questions, whereas normally we can just move through life without having to do all that analysis. So if it's a simple example like trying to learn a new language or a new motor skill or a new way of conceptualizing something, maybe somebody's in a therapeutic process and they're trying to work through a trauma or something like that, duration, path, and outcome is built into the networks of the brain. We can do that very easily, but it takes work. And it almost has a feeling of underlying agitation and frustration. And that's because the circuits that turn on before acetylcholine are of the stress system. So when you or I decide we're going to learn something and really dig in, Norepinephrine, which is adrenaline, is secreted in the brainstem and in the body, and it brings about a state of alertness. Then our attention, which is mostly a diffuse light, is brought to a particular duration, path, and outcome analysis. This would be thinking about what somebody is saying. What are they really trying to say? A hard passage of reading, a hard, set of math problems, a challenging physical workout. When you do that, these two systems have to work very hard, and the adult brain doesn't really want to change the algorithms it learned in childhood. But if you do those two things, you have alertness and focus. The acetylcholine and the norepinephrine converge to mark those synapses for change. And so the way to think about neuroplasticity, if one wants to change their brain, is bring about the most intense concentration you can to something, and then later bring about the least amount of concentration to that thing. There were some studies that were done at Stanford by a guy named Eric Knudsen that showed that plasticity in the adult brain, any age, can be as robust as it is in childhood, as fast and as traumatic, provided the focus is there, and it's all contingent on this acetylcholine molecule coming from nucleus bassalis. The right approach is to bring as much focus to a behavior, or to a thought, or to an action pattern. And there has to be a sense of urgency. So what Knudsen lab showed, and another lab at UCSF, Mike Merzenich's lab, showed, is that if there's a serious contingency, like in order to get your ration of food each day, you have to learn this thing, the degree of plasticity is remarkable.
Right.
But if there isn't an incentive, it just isn't going to happen. So these circuits in the brain that Mother Nature set up are designed to be anchored to a real need. And people always say to me, well, should I do something out of love and a real desire to learn, or should it be out of fear? Either one works. The sense of urgency is just acetylcholine. It's norepinephrine. That's all it is. The brain doesn't have a recognition of whether or not something is pleasurable or not until later. Once you start accomplishing your goal, the reward systems like dopamine start kicking in. But I think if people are interested in modifying their brain for the better, at least some, top contour understanding of how urgency and focus must converge for that to happen can be useful, because I think there's a lot of attention paid to whether or not something feels like flow, or whether or not it's what I call highly desirable states, or whether or not you can eat a plant out of the ground that will magically put your brain into a state of plasticity. And the answer is yes, such plants exist, but what's missing is the focus component. If that work is not done with a particular end goal in mind, you'll get plasticity, but you'll get plasticity in a kind of across the board. It's like learning a little bit of 9 languages all at once is not going to make you speak coherently in any one of them. So focus is the key.